So we will continue looking at reviewing factoring. Yeah. So if you were here the last two classes, you'd have it because we've been going through it. Huh? You were here the last two classes, weren't you? So there's up here, but not just you, but everyone. You can't just not bring this stuff because I do have a few extra copies, but I don't have enough where you can get a new one every day. So put them in your binder so you have them and they don't get lost, okay? Because I've only got a few extras left now. After that, I'm not going to print off any more. Page 13. So there is a part of the final exam where you have to factor. So you got to know how to factor. It's going to be on there. I'll tell you right now, there's a whole page of factoring. So I don't remember if there's maybe 7 or 8 different polynomials that you have to factor. Remember that your final exam is on Monday. That's a week from today at 8:30 in the morning here in this room. It's different than what's published on the exam schedule for 10C, and I've told you before because I'm away to mark diploma exams, I won't be here when the regular 10C exam is being written. So ours is at a different time. So you need to make sure that you're here Monday morning for that exam. And there are questions on there where you're going to be asked to factor the polynomials. The first thing you always look for is a common factor. If there is a common factor, you take it out, and we'll see examples of that as we continue to go through this. Then you look to see what kind of polynomial you have. If it's a trinomial, we've seen that trinomials can sometimes be factored by finding two binomials that multiply together to get that trinomial, because that's what factoring is, finding things that multiply together to get what you start with. So if there is no common factor in a trinomial and it is factorable, the factors will be binomial factors. So we'll put down a double set of brackets. On the final exam, you will be able to factor all of the polynomials. We've seen in different examples that sometimes you'll get ones that can't be factored in examples. But on the final exam, if the question asks you to factor a polynomial, it can be factored. So for this first one, the front terms of the binomials multiply to get m squared. So that's why I have an m and an m. And now remember, you're looking for two numbers that multiply together to get 10, add to get negative 7. They multiply to get a positive 10, which means their signs have to be the same. Because they add to get negative 7, they both have to be negative. The numbers that work here will be negative 2 and negative 5. They do multiply together to get positive 10, and they do add together to get negative 7. Remember, you can always check by multiplying. Use distributive property. So when you multiply out, m times m is m squared, m times negative 5 is negative 5m, negative 2 times m, and negative 2 times negative 5 is plus 10. So this will be m squared minus 7m plus 10, which is what we started with. So we've just shown that our factors are correct. They do multiply together. Okay, thank you. All right. So it checks. Question B. No common factor there. So if there are factors, they'll be binomial factors. The front terms multiply to get s squared, which means we have s and s. The last two, the numbers multiply to get negative 10, add to get positive 3. So because they multiply to get negative 10, their signs have to be different, one positive, one negative. They add to get positive 3, so the bigger number has to be positive. Positive 5 and negative 2 work. Now you can put the negative 2 in the first bracket, the positive 5 in the second. That doesn't matter. Those are the factors. And we can check. So the s times s minus 2 and the positive 5 times s minus 2 gives us s squared minus 2s plus 5s minus 10, or s squared plus 3s minus 10, which is what we started with, so that just verifies that our factors are correct. You can always check your factors by multiplying. All right, question C. There's no common factor there. It's a trinomial, so if there are factors, they will be binomial factors. The front terms multiply to get f squared. And we're looking for two numbers that multiply to get positive 6, add to get negative 7. They multiply to get a positive value, so their signs have to be the same. They add to get negative 7, which means they both have to be negative. Negative 1 and negative 6 work. They multiply to get positive 6. They add to get negative 7. Those are the factors. And you can check by multiplying. I'm not going to, but you could. D. No common factor there. It's a trinomial, so if factors exist, they'll be binomial factors. The front terms have to multiply to get g squared, so they're both g's. And now we're looking for two numbers that multiply to get negative 14, add to get negative 5. Negative 7 and positive 2 work. They multiply to get negative 14, they add to get negative 5. Those are the factors. And you could check by multiplying it out, you would get what you start with. Question E. No common factor there, so if there are factors, they'll be binomial factors. The front terms multiply to get b squared. The last terms multiply to get negative 4, add to get negative 3. Negative 4 and positive 1 work. They multiply to get negative 4, they add to get negative 3. So they work. Those are the factors. Looking at question F. This one does have a common factor of 2 that you would take out first. And remember, when you take out a common factor, you divide each term by the common factor to get the other factor. So you divide all three terms by positive 2. That's why 2 is the common factor, because all three terms are divisible by 2. And the trinomial that's left, let's see if we can factor that further. Because the front terms multiply to get r squared, you need an r and an r. The last terms have to multiply to get 12s squared. So that means that those last terms both have to have an s, which is where the s squared will come from. And to find out what the numbers are, we want to find two numbers that multiply to get 12, add to get negative 7. Negative 3 and negative 4 will work. You can have the negative 4 in the first bracket, the negative 3 in the second, it doesn't matter. But those are the factors. Okay? So again, there will be questions on the final exam where you have to factor. There's a page with 6 or 7 of them of the different types. So make sure you know how to do all the different types of factoring. We looked at ones like this where there was a number in front of the squared term. So there is no common factor for question A. So if there are factors, there will be binomial factors. In this case, the front terms have to multiply to get 2x squared, which means you need a 2x and a 1x. The last terms multiply together to get 5, and they don't add to get 7. We have to find two numbers that multiply together to get 5, and then when we multiply out, we get a positive 7x in the middle. And this will work, I think, if we put a plus 5 there and a plus 1 there. And here's how I know that. When you multiply the 2x and the x, you'll get the 2x squared. When you multiply the last terms, the 5 times the 1, you do get plus 5. When you multiply the outer terms, 2x times 1 is 2x. The inner terms, 5 times x is 5x. 2x plus 5x does equal 7x. That's how I know that those are the correct factors. Remember that we've checked them by multiplying, so you can do that as well. Actually show the multiplication. You won't need to do this on the final exam. You won't be asked to check your factors. This is just something that you might do just so you know whether you have the right answer or not. 2x and 5x is 7x. So those are the correct factors. They check. All right, question B. There is no common factor. So if there are factors, they'll be binomial factors. The front terms multiply to get 6y squared. Now in this case, you could have 2y and 3y or 6y and 1y. I always start with the numbers that are closest together. 2y and 3y. They multiply to get your 6y squared. Now I'm looking for two numbers that multiply to get positive 8. So that could be 2 and 4 or 1 and 8. Now you might remember when we did these, we said you wouldn't have, if this first term is 2y, the number in this bracket that goes with it would not have a common factor with the 2y. Thank you. So because of that, excuse me, I wouldn't be able to use 2 times 4 to get this 8. So no matter if I put a 2 there or a 4 there, it would have a common factor with the 2y, and that wouldn't happen. But I could have a 1 there and an 8 there. That one might still work. Because they multiply to get a positive 8, both numbers have to be positive. The middle term is positive 19y, which confirms that those two terms would be positive. Now, the front terms, 2y times 3y is 6y squared. The last terms, 1 times 8 is 8. The outer products would be 16y. The inner products, 3y. 16y plus 3y does give you the 19y. So it checks. Those are the correct factors. If you wanted to show the check, you would actually multiply out using the distributive property. So it'll be 6y squared plus 16y plus 3y plus 8, or 6y squared plus 19y plus 8. That is what we started with. That confirms that the factors are correct. Remember, factors are things that multiply together to get what you start with. All right, looking at question C. I'm just going to write it out here. 3m squared plus 10m plus 8. No common factor there. So if there are factors, they will be binomial factors. And the front terms multiply to get 3m squared. So that's a 3m and a 1m. The last terms multiply together to get 8. So it could be 2 and 4 or 1 and 8. Let's try 2 and 4 like this and see if that works. So the front terms do multiply to get 3m squared. The last terms do multiply to get 8. The outer product will be 12m, the inner product 2m. Well, they add to get 14m, not 10m. So that doesn't work. But what if we put the 4 in the first bracket and the 2 in the second bracket? Now the outer product is 6m and the inner product is 4m. They do add to get 10m. So these are the factors. The front terms multiply to get 3m squared. The last terms multiply to get 8. The outer product are 6m, the inner product 4m. They add to get 10m. So those are the factors. And that one is done. You could check 2 by multiplying, which we have done some of those. So the next one is E, 12q squared plus 17q plus 6. No common factor there. So if there are factors, they'll be binomial factors. The front terms multiply to get 12q squared. I will try 3q and 4q first, the ones that are closest together. If I can't get those to work, then maybe I'll try 2q and 6q or 12q and 1q. But I normally start with the numbers that are closest together. Same thing for the last terms, multiply to get 6. I'm going to try 2 and 3. And I would put the 2 with this 3 and the 3 with this 4. You wouldn't have a 3 with a 3, and you wouldn't have a 2 with the 4, because there's common factors there. So let's see if this works. The front terms do multiply to get 12q squared. The last terms do multiply to get plus 6. The outer products are 9q. The inner products are 8q. 9q plus 8q does equal 17q. So these factors are correct. They do work. Okay? They do work. We just checked them. So the next one is question F here. 3x squared plus 7xy plus 2y squared. All right? Front terms multiply to get 3x squared. So I'll try a 3x and an x. The last terms multiply to get 2y squared. So we know we have to have a y in each spot. And the only thing that multiplies to get 2 is 1 times 2 or 2 times 1. If you put the 2 there and the 1 there, you won't get 7xy in the middle. You'll get 3xy plus 2xy, which is 5xy. But if you switch them around and put the 1 here and the 2 there, the outer products are 6xy, the inner 1xy. They do add to get 7xy. Both of them are positive because they multiply to get positive 2y squared, and you need a positive 7xy in the middle. So those are the factors. And you could check by multiplying out, like we have done. Okay, I think we've done enough of those, so let's skip to the next page here, which is number 16. These are difference of squares, a different type of factoring. Difference of squares happens when you have two terms, minus sign in between, and both terms are perfect squares. So I think this is page 16 in your package. Is it 15 in yours? Oh, I must have added another page in there somewhere. Okay, doesn't matter. So, when you factor difference of squares, they're binomial factors. Once you recognize this difference of squares, they're easy to factor. The square root of x squared is x. That goes there and there. The square root of 16 is 4. Because the x squared is the first term, x's go in the first position of the binomial. 16 is the last term. The square root of 16 is 4. They go in the last position of the binomial. Then, one's a plus, one's a minus. That's how you factor difference of squares. You can check by multiplying using the distributive property. That'll give me x squared minus 4x plus 4x minus 16. Well, the 4x's cancel when you multiply those out. And you get x squared minus 16, which is what you started with. That just confirms that the factors are correct. When you multiply x plus 4 and x minus 4, the 4x's cancel like we saw here. So there's your factors. That one is done. Question B is difference of squares. Because the square root of b squared is b, the square root of 121 is 11. One's a plus, one's a minus. It's done. You can check by multiplying, but it'll work. The last terms multiply to get negative 121 because you have a positive 11 times a negative 11. Now C is not difference of squares. It's sum of squares. You see you have a plus sign in between the x or the w squared and the 169. So 169 is a perfect square. The square root of that is 13. But this is a sum of squares, not a difference of squares. This is not difference of squares. There is no common factor. It cannot be factored. And again, on the final exam, all the questions you're asked to factor are factorable. So you won't get any that aren't. But when we did examples in class, we saw sometimes some that were not factorable. Question D. Doesn't matter that you've got the 9 in front of the a squared and the 16 in front of the b squared. This is difference of squares. The square root of 9a squared is 3a. You take the square root of the 9 and the square root of the a squared. The square root of 16b squared is 4b. You take the square root of the 16 and the square root of the b squared. One's a plus, one's a minus. It's done. It's factored. Right? Question E is difference of squares, because you have two terms, they're both perfect squares, and there's a minus. Actually, hold that thought. They're not both perfect squares. This one here, there is a common factor of 3 to take out first. (121) divided by 3 is, no, that's not true either. There is no common factor of 121 of 3. There's not a common factor of 4. Yeah, I don't think this one is factorable. 121, I think, is a prime number. Oh, E. I was looking at G. Okay, thank you. I was looking at G. Question E is difference of squares. The square root of 36c squared is 6c. Square root of 49d squared is 7d. One's a plus, one's a minus. It's factored. F, there are no factors. It is a sum of squares. You cannot factor sum of squares. And I don't think, we talked about G already. I don't think there is a common factor there. Because it's not divisible by 2. It's not divisible by 3. Those two numbers differ by 3, so yeah, that one can't be factored. I don't think there's any factors for that one. But H can be factored. That is a difference of squares, because the square root of 100 is 10. The square root of 9t squared is 3t. One's a plus, one's a minus. There's your factors. Okay. Number 6. If we look at question A, that's a trinomial, no common factor. If there are factors, they'll be binomial factors. X times x will give you the x squared. You're looking for two numbers that multiply to get 36, add to get 12. Well, positive 6 and positive 6 work. This can be written as x plus 6 all squared, because you have two factors of x plus 6. This trinomial is known as a perfect square trinomial, and we looked at those. Once you recognize that they're perfect square trinomials, they're easy to factor. So here's how you do that. The first thing that has to happen is that the first and last terms have to be perfect squares, which they are. The square root of x squared is x, so that's that x there. The square root of the 36 is 6, so that's why we got a 6 there. But the other thing that must happen is if you multiply these two together and double, you need to get the middle term, which you do. 6 times x is 6x, doubled is 12x. And the nice thing about these is once you recognize it's a perfect square trinomial, they are easy to factor. So question B is another example of a perfect square trinomial. The first and last terms are perfect squares, so that's where you start. The square root of x squared is x, the square root of 25 is 5. But that's only the first part. If you multiply these together and double, you need to get the middle term, and you do. So it is a perfect square trinomial. X times 5 is 5x, doubled is 10x. Because it's positive 10x, it'll be x plus 5 all squared. If you did this the way we did part A first, you'd get x plus 5, which is x plus 5 squared. C is not a perfect square trinomial because the last term is negative 144. It's not a perfect square because of the negative there. Okay? So, let's see if it is factorable. We'll try and find some numbers that multiply together to get 144 by kind of working backwards. 4 times 36 is 144, but they don't differ to get negative 24. So let's go 144 divided by 8. 8 and 18 do give you, when you multiply together, they get 144, but they add to get 26, not 24, so that doesn't work. I'm trying to find two numbers that might multiply together to get 144 and add or subtract together to get negative 24. 144 divided by 9, I think, is 16. Yes, but 9 and 16 add to get 25, not 24. So I don't think there's any factors for this one. But again, on the final, if you're asked to factor a polynomial, it will work. D might be a perfect square trinomial, though, because the square root of m squared is m. The square root of, whoops, I put down an extra set of brackets that I don't need here. The square root of 169 is 13. If you multiply those together and double, you do get 26m. And because it's a minus 26m, it'll be m minus 13 squared. If you did this the other way, you'd get m minus 13, m minus 13. Right? Question E might be a perfect square trinomial because the first and last terms are perfect squares. The square root of 16k squared is 4k. The square root of 1 is 1. If you multiply those together and double, you do get 8k, which is the middle term. But because it's a minus 8k, it'll be 4k minus 1 all squared. There's your factors. Question F might be a perfect square trinomial. The square root of 49 is 7. The square root of m squared is m. When you multiply these together and double, you do get 14m. And because it's a minus 14, it'll be 7 minus m, all squared. Question G might be a perfect square trinomial. The square root of 81u squared is 9u. The square root of 4 is 2. If you multiply these together, you'll get 18u doubled is 36u, not 34u. So it's not a perfect square trinomial. It's not. Because they don't multiply these two together and double, you need to get the middle term. And that doesn't work. So there are no factors for this one. Question H, and this is really the value of these perfect square trinomial types. Often when you get big numbers that you need to factor, often they'll be perfect square trinomials. It makes it much easier to factor. The square root of 36a squared is 6a. The square root of 49 is 7. If you multiply these together, you'll get 42a doubled is 84a. And because it's a positive 84a, it'll be 6a plus 7 all squared. So there's the factors. Okay? So looking at number 7. Remember, always look for a common factor first. And there is one here, common factor of 5 to take out, which will give you t squared minus 20. And that is not difference of squares because 20 is not a perfect square. After you factor once, always look at see what you're left with to see if it can be factored again. In this case, it can't. Question B, there is a common factor there of 10xy. If you divide the first term by 10xy, you'll get x squared minus. When you divide this 90xy by 10xy, you'll get 9. And that is difference of squares. X squared minus 9 is difference of squares. The square root of x squared is x. The square root of 9 is 3. One's a plus, one's a minus. There's the factors for that one. After you factor once, check to make sure it can't be factored again. Question C. Could potentially be a perfect squared trinomial because the square root of 4x squared is 2x, the square root of 36 is 6. However, when you multiply these together, you'll get 12x. Doubled is 24x, not 48x. So it's not a perfect square trinomial. However, there is a common factor of 4 there. So let's try that. You'll get x squared minus 12x plus 9. And that one is now factored. This x squared minus 12x plus 9 cannot be factored any further. There are no two numbers that multiply to get 9 and add to get 12. Won't work. But we still factored. We took out a common factor of 4. So we did factor it. Question D. In this case, there is a common factor there of x. And if you take it out, you'll get 18x squared plus 24x plus 8. I'm sorry, not just x, but 2x. Apologize for that. There's a common factor of 2x there, which will give us 9x squared plus 12x plus 4. And this trinomial looks like it may be a perfect square trinomial because 9x squared is a perfect square. The square root of that is 3x. 4 is a perfect square. The square root of that is 2. If you multiply them together, you'll get 6x doubled is 12x. Because it's a positive 12x, it'll be 3x plus 2 all squared. There's your factors. Question E is a difference of squares. The square root of x to the 4th is x squared. And the square root of 16 is 4. One's a plus, one's a minus. But this one isn't done just yet because you can't factor a sum of squares, but the x squared minus 4 is difference of squares again. The square root of x squared is x. The square root of 4 is 2. One's a plus, one's a minus. Now it's factored. Now it's done. After you factor once, always check to see if it can be factored again. Question F, when you look at that, again, the first and last terms are perfect squares, so it may be a perfect square trinomial. The square root of x to the 4th is x squared. The square root of 81 is 9. If you multiply these together and double, you do get 18x squared. And because it's a negative x squared, it'd be x squared minus 9 all squared. And x squared minus 9 is a difference of squares. It'll be x plus 3, x minus 3. Because the x squared minus 9 was all squared, so will the factors of it. There's your factors. Okay? So there are some pages, and these are out of your textbook if you want to do some extra practice on this chapter, on this unit. I would suggest going to the textbook, and this chapter 4 practice test is in your textbook after chapter 4. Then there's also one for chapter 5 practice test. You can try these questions. The answers are in the back, so you can go back and check your answers. I also gave you a sheet on Friday, a review sheet for this stuff. and I posted those solutions on Google Classroom as well. So there's lots of stuff that you guys can be working on for the rest of this class. Tomorrow, we will start getting into the next unit, which is chapters 6, 7, and then 8 and 9. We'll be doing some review for those topics. Okay, so either work on the sheet I gave you Friday or the chapter 4 and chapter 5 tests in your textbook, and you can check the answers for those in the back of your textbook. Okay, and again, remember, Monday, week from today, is your final exam here at 8:30 in the morning.